Greetings! In this video, we are going to talk about these 4 elements. Firstly, introduction to elementary row operation. Secondly, rule of ERO and some special tips to check our answer. Thirdly, ways to solve inverse matrix using ERO method. And last but not least is how can we apply this method in real life situation. By the way, hi guys, I'm your friend Jack and I'm the one who is going to introduce ERO method to all of you. A little bit about me, I'm currently pursuing my study at University Technology Malaysia, majoring in Mechanical Engineering from SSCE 1693, Section 40. Hope you find our video useful. Okay, first of all, let us recap back. What is a matrix? A matrix is a rectangular array of numbers arranged into columns and rows. Secondly, matrix algebra is used in statistics to express collection of data. Thirdly, it provides a theoretically and practically useful way to solve mathematical problems. I'm going to show you an example here. Alright, in this example, we can see there are numbers in red and green colors. The red represents row, while the green color stands for column. Notice that the Aij indicates the element in the I row and the J's column. For the example below, we can see the first A is 3 times 3 matrix and the second one B equals to 3 times 1 matrix. So in this section, we are going to talk about inverse matrix. Well, we all have learned this before. Just to recap, if A and B are n times n matrices, then the matrix B is the inverse of matrix A, or vice versa. If and only if A times B equals to B times B equals to the identity of matrix. Alright, now we look at what is an elementary row operation method, ERO. So ERO is a simple operation that allows to transform a system of linear equation into equivalent system. So there are actually 3 main ways to solve ERO equation. Well, the first one is swap rows. The second one is multiply or divide each element in a row by a constant. Or thirdly, we can replace a row by adding or subtracting a multiple of another row to it. Next, I'm going to brief and show you the overview of how are we going to apply ERO method. And my friends GK, Wern and Clem will further explain it to you in details later. So please stay till the end of the video. So in the left side is the overview of the ERO method. We are gonna change A into I and I change to inverse matrix. So we are gonna find by using the step that I'm gonna show you. Now firstly, we are gonna identify the given metric and put it into the form that I show you in the right bottom of this video. And then we are going to use the step that I mentioned just now, add, subdivide, and subtract. And don't forget that I is identity matrix. Actually, there are no right way to do this ERO method. Just do it until we get the left side, we get the identity of the metric, and the right side is our answer, inverse matrix of A. Yeah, that's all from me. So I'm going to invite my friend GK to introduce to you the rules of ERO and what the other special tips to help you to check the answer. Thank you so much for listening.
Thanks Jack, and hi everyone, my name is GK and I am from the same course and section. So in order to do elementary row operation, there are several rules to follow, or I would say several methods to use. First of all, you can interchange between 2 rows. Secondly, you also can multiply a row by a non-zero scalar. Lastly, after multiplying the row, you also can add this row to another row in order to form a new row.
Hello everyone, my name is Wern. I am a first-year undergraduate mechanical engineering student and I am from section 40 engineering mathematics. So, how do we find inverse matrix by using ERO, which stands for elementary row operations? So, there are 4 steps in finding inverse matrix by using ERO. Just 1. We will let A or any variable we want to the matrix given by the question. Secondly, we will write it in the form of bracket A / I, where I is an identity matrix. Thirdly, we'll change it by using ERO into the form of bracket I straight line B, where the resulting B is the inverse of matrix A. Question time. Question 1. Find the inverse matrix by using ERO. By using the concept and the steps we have learned just now, firstly, we will assign a variable to the matrix given by the question. In this case, I use A. Then we write it in the form of bracket A straight line I, where I is an identity matrix. In this case, we use a 3 times 3 identity matrix, since the matrix given by the question is also a 3 times 3 matrix. By performing elementary row operations, firstly, we will change this value to become 1, since its corresponding value in the identity matrix is also 1. So how do we do that? We use -1 times the first row, and then minus with the second row, and then we put it back to the first row. -1 times -3 we will get 3. Then minus the second row, which is these 2, and -2, and then we will get 1. And don't forget, the other values in the first row will be changed too. Then we will try to make this value to become 0, since its corresponding value in the identity matrix is also 0. Thus, I use row 2 minus 2 times R1 and then I put it back to R2, and you realize that this value has become 0. So basically, we will be playing around with the 3 rules that we have learned just now, and we will keep performing ERO for the following number. And then we will do until we get identity matrix on the left part. Hence, now we can stop our elementary row operation and the whole right part will be our answer. We will rewrite it again, hence the inverse matrix of A is equal to the whole right part. Question 2. Find the inverse matrix by using elementary row operation. So how do we do that? We will do the exact same thing as question 1. Firstly, we will assign a variable to the matrix given by the question. In this case, I use B as my variable. Then, I will write it in the form of bracket B straight line I, where I is an identity matrix. Thirdly, I will perform the elementary row operation and slowly change each value until I get my whole left part equals to the identity matrix. Lastly, stop the ERO when we get the identity matrix on the left part, and then the whole right part will be our final answer. But how do we know whether our answer is correct or wrong? Please continue watching.
Okay, so did my friend Wern did the ERO correctly? Let's find out. So if the inverse matrix found is true, we should get the identity matrix, which is I, after we multiply it with the original matrix. The working is shown in the video. Let's check it out.
Hello everyone, it's Clem here. And just a brief introduction, I'm a first year undergraduate student in Mechanical Engineering at University Technology Malaysia. And now we are going to apply what we have learned throughout this video in a real life situation. Let's go! So Jack wants to buy a hamper for his friend, Wern. Each hamper consists of items A, B and C at different quantity. The first hamper consists of 1 item A, 3 item B and 3 item C, priced at 245 ringgit. The second hamper consists of 1, 4 and 3 items A, B and C respectively, resulting in a price of 280 ringgit. The third hamper consists of 1 item A, 3 item B and 4 item C, which costs 285 ringgit. Jack is curious and wants to know the price of each item in the hamper. Determine the price of item A, B and C respectively. We put these equations into the form of matrix. So the first row would be 1, 3, 3 for the first hamper, 1, 4, 3 for the second hamper, and 1, 3, 4 for the third hamper. And we have A, B and C equals to 245, 280 and 285. We need to find the inverse of this matrix, and in order to find this inverse we will be using the elementary raw operation, which is the ERO. And in this ERO we will write the matrix down, which is the matrix above, and draw a line and on this other side we'll be writing the identity matrix. So our main point is to make the left side of this matrix become the identity matrix, and on the right side of this matrix it will be the inverse of this matrix. First, I'm going to approach it by writing down negative R2 plus R3. So the first row and the second row, I'll be just writing down the same matrix as the previous one, and the third row would be negative 1 plus 1, which is 0, negative 4 plus 3, negative 1, and negative 3 plus 4 is 1. So on this side is negative 0 plus 0 is still 0, negative 1 plus 0 is negative 1, and negative 0 plus 1 is 1. Next, we'll use negative R1 plus R2. So the second row would be negative 1 plus 1, which is 0, negative 3 plus 4 is 1, and negative 3 plus 3 is 0. On the other side is negative 1 plus 0, negative 1, negative 0 plus 1 is 1, and negative 0 plus 0 is still 0. Next, we're going to approach by using R2 plus R3, and the third row would be 0 plus 0 is 0, 1 plus negative 1 is 0, 0 plus 1 is 1, and on the other side, negative 1 plus 0 is negative 1, 1 plus negative 1 is 0, and 0 plus 1 is 1. Next, we are going to use negative 3R2 plus R1. So the first row would be negative 0 plus 1, which is 1, negative 3 plus 3 is 0, and negative 0 plus 3 is 3. On the other side, 3 plus 1 is 4, negative 3 plus 0 is negative 3, and 0 plus 0 is still 0. Next, we'll approach it with negative 3R3 plus R1, which is our last step. So the first row will be negative 0 plus 1, which is 1, negative 0 plus 0, which is still 0, and negative 3 plus 3, which is 0. On the other side, 3 plus 4 is 7, 0 plus negative 3 is negative 3, and negative 3 plus 0 is negative 3. So here we have the inverse matrix of this question. So after we find the inverse matrix of this equation, we're going to times it with 245, 280, and 285. The final answer will be 20, 35, and 40. So that's all from our side. Thank you for listening and have a nice day.